consider the proposition, we have the sum notation or the sigma notation, right? With n on the top and k down the bottom with 2k minus 1 equals to n squared. So which of the following is true for p of k plus 1? It's kind of like your mathematical induction question here. Now, most of your multiple choices, you should be able to cross out an answer straight away. So such as your A, right? In this case, clearly it does not fit with the other three. Usually it's just the case that it's not the correct answer, but we do have to test out. But for now, let's just assume A isn't correct and let's look at B, C, and D. What we see is we all have the sum, right? From k equals to 1 up to k. Right, this means that when we have p equals to k, right, so just row 2 of the right side bracket. When we do have p equals to k, what we have is sum, right, n equals to k, and then we're starting with 1, and we do have the 2k minus 1. Right, that's when this is our proposition, and by saying that let n equals to k, this is what we get, right? And now let's look at the things next. They are plus, 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 and we can see with C and D, what we're seeing is k plus 1. So essentially, I'm plussing the extra term of p of k plus 1, right? We know that sigma notation means everything is just added together, right? So if it's 2k minus 1, right, we're starting from 1. Essentially, this summation is just, we're starting with 2 times 1 minus 1, and then plus 2 of 2 minus 1, and then plus all the way until we have our k, and then minus 1, right? We'll have this summation continuously going on. So, however, we kept the summation together, so all we need is to figure out our p of k plus 1's term, right? So our p of k plus 1 term, by subbing it in, is just 2k plus 1 minus 1, right? I get 2k plus 2 minus 1. So I get 2k plus 1. Right. So we have the summation of the starting from k equals to 1 until k equals to k. And then we'll be plussing this k plus 1 term. And now let's look at the right hand side. We have n, right? So now because we're letting, for the equation, we're letting n equals to k plus 1. So on the right hand side, we should also get k plus 1 squared, which all of them does have. But now let's look at, so our final proposition should be k plus 1 should be equal to, from 1 to k, right, which is the series, which is the summation series, doesn't change, and plus our k plus 1's term, which is 2k plus 1. Okay? And our right-hand side, because we are letting n equals to k plus 1, so what we will get is k plus 1 squared. Okay? So our option here should be D.